Types of sampling techniques. Based on the nature, size, composition, settlement, and other factors of the population from which sample is to be selected, there are two categories of sampling: the probability sampling techniques and non-probability sampling techniques. In probability sampling, each element of the population has fixed probabilistic chance of being included in the sample. While in non-probability sampling, being member of a sample depends on personal judgment, that is, subjective view or opinion of the person who takes sample from the population of interest. There are different types of probability sampling, like simple random sampling, systematic sampling, stratified sampling, and cluster sampling. On the other hand, non-probability sampling involves convenience sampling, judgmental or purposive sampling, and quota sampling. Let us first see about the concept of random sample. The concept of random sample. Suppose a finite population comprising 5 elements A, B, C, D, and E. These 5 elements might be the income of 5 managers, the price of 5 television brands. Of these n equals 5 elements, 10 possible samples of size n equals 3 can be selected by using the combination rule stated hereunder as follows. 10 possible random samples of size n equals 3 can be selected. When we select one of the 10 possible samples in such a way that each has the same probability of being selected, then the selected sample is random sample. Whereas if 2 of the 5 elements are top-level managers, and we deliberately selected these 2 managers as our sample, the sample is non-random sample because all elements of the population don't have a known or non-zero chance of being included in the sample, and this technique of sampling is called non-probability sampling. 1.2.1 Techniques of probability sampling. A. Simple random sampling. Simple random sampling is a technique in which sample is selected in such a way that 1. Every element in the population has a known or the same and equal chance of being included in the sample, and 2. Every sample of size n has the same chance of being chosen. Example. Suppose Bethania, Charles, David, and Esther are the employees working in the insurance office of the Sunshine PLC. All of them wants to go for vacation in the summer, but only 2 can be away at the same time. Consequently, the personnel manager used a lottery or blind draw method, that is, he prepared 4 pieces of paper having the February 1st letters of their name. Now, of the possible samples of size n equals 2, BC, BD, B, CD, C, D, the chance of selection of every element of the population is n/n. B appears in 3 of the 6 possible samples. So, the probability of B to be selected or included in the sample of size 2 is 3 divided by 6 is equal to 0.5. Similarly, PC, PD, PE equals 1/2 equals 0.5. So, each element of the population has the same chance of being chosen for vacation period. Moreover, every sample of size n equals 2 have the same chance, i.e. 1/6, of being selected. Simple random sampling is used in research when we believe each element of the population has the same information about our interest. For instance, if a researcher wants to study about the tidal war damage assessment and post-war rehabilitation in Ukraine, the population for this research would be all citizens of the country. Every citizen has full awareness about the war damage incurred in Ukraine. Therefore, we can randomly select sample citizens using simple random sampling technique from the country in order to gather relevant data. B. Systematic random sampling. In this technique, every KTH element in the population sequence is selected. Regarding the steps to be followed, first of all, order the population in a certain way. Then, a sampling interval K is calculated. Sampling interval equals population size / sample size. Example. Assume the Federal Audit Commission is ordered by Ministry of Finance to audit Pandam University's financial performance at the end of a given year. There are a population of 100 critical financial documents to be audited by the team. Because of time and cost matters, the audit team has preferred to audit a random sample of 20 documents and generalize over the whole population based on the audit result of the sample. Then, first of all, the population of documents showing financial performance of Pandam University has been ordered according to days. Now, sampling interval K is equal to population size over sample size, then population size is 100 and the desired sample size is 20. Therefore, 100 divided to 20 equals 5. The necessary step we should follow is First, select any number between 1 and 5. For example, let we select 3. Now the starting point will be 3. This means after putting the documents in certain order either in time, type, or other measurement, we start selecting our sample with the third element. Then, continue to add the sampling interval to the starting element, that is 3, until you reach your sample size of n equals 20 elements. Accordingly, the sample elements will be 3, 8, 13, 18, 23, 28, 33, 38, 43, 48, 53, 58, 63, 68, 73, 78, 83, 88, 93, 98. This means, from the ordered sequence of the documents, the 3rd, 8th, 13th, 18th financial documents would be selected or being included in the sample for audit or critical investigation. In systematic sampling, the selection of a unit is dependent on the selection of a preceding element, in contrast to simple random sampling where the selection of units is independent of each other. See stratified random sampling. Strata refers to groups of homogeneous behavior. Stratification means splitting the population consisting different characteristics into the subgroups possessing common characteristics. Stratified random sampling is used in situations where the population is heterogeneous by nature. Stratified random. In this method, the population elements are divided into strata on the basis of some characteristics, and from each of these smaller homogeneous groups draws at random a predetermined number of units. Stratified random sampling can be of two types. 1. Proportionate stratified sampling, and 2. Disproportionate stratified sampling. When the size of the sample is proportionate to the size of the unit, it is called proportionate stratified sampling. When it is not proportionate to the size of the unit, it is called disproportionate stratified sampling. Disproportionate stratified sampling depends upon considerations involving personal judgment and convenience. For example, suppose there are n number of students in Warrambo University, further divided into subpopulations of various faculties like social science, arts, science, engineering, management, and medicine. It is a well-established fact that students of different faculties have different personal characteristics like reading habits. Hence, each faculty would become our stratum. A practical example is presented below. Let us see the following illustrative example. Cluster sampling. Cluster sampling is also called area sampling. Cluster sampling is a technique of probability sampling used to study large population containing naturally formed groups, clusters, with the objective of cost efficiency and convenience. Cluster sampling can be one-stage, two-stage, or multi-stage. The necessary steps to be followed during selecting sample elements using cluster is 1. Divide the whole population based on the natural category into clusters and then select random sample of clusters. 2. For each selected cluster, either all elements within the selected clusters are involved in the sample or a sample of elements are selected from each early selected cluster probabilistically. Suppose a researcher wants information about attitude on working condition from workers in the factories of large industrial area. List of the thousands of workers is not available and would be costly to compile. However, it is easy to compile the relatively small list of factories within the industrial area. We may then select a simple random sample of factories or sample clusters and interview all employees within the selected factories, or draw a random sample of workers from the selected cluster of factories. Cluster sampling is economical, but may result in low precision of results because the goal of sampling is to achieve a desired degree of precision at low cost. In cluster sampling, only a fraction of the clusters in a population are sampled. The remaining clusters are ignored. Precision will suffer if the ignored clusters are not similar to the sample clusters. Consequently, cluster sampling works better for homogeneous population. Let us see one illustrative example below.